Hello, everyone. My name is Alan Cha. I am a software engineer at IBM Research, and today I'm joined with...
My name is Mariusz Sabath. I'm a senior technical staff member in IBM Research, and we'll be talking today about agents.
Okay, so who will let the agents out, securing AI workloads the right way? As developers, we typically work with multiple external tools every day, such as GitHub and Slack. We often need to do repetitive tasks, such as reading new issues on GitHub or sending messages to fellow maintainers on Slack. So as developers, we're constantly wondering, is there a better way? Well, one solution that is becoming increasingly more popular is using agents. With agentic applications, we remove a lot of that manual labor, like directly logging into GitHub and going through different channels on Slack. Instead, instead of a user interfacing with all these tools individually, they can go to a single agent with a single interface, and that agent can take care of all these different tools. Many of us have played with local agents like Claude Desktop or various VS Code extensions, and enabling local agents is easy. You know, you can just put your API key in an environment file, and the agent can now act on our behalf. But it gets tricky when the agent lives in the cloud, all right? Suddenly, we as an organization are responsible for the behavior of this agent. It's important that the right security controls are in place. So we're all here at Open Source SecurityCon, and we'll focus on that aspect. And the lens that we'll be using is Zero Trust. Zero Trust is all about enforcing least privilege per request access decisions. And by least privilege, we mean actors only get the minimum access required to perform a task. And by per request, we mean that every action requires fresh authentication and authorization. So let's go back to this remote case. We want zero trust. We want all these components to be locked down. Every request should be verified, and credentials should be passed around blindly. You can think of it this way. Each part of the system needs to understand the context of every request. The agent should know who the user is, and the tool should know who or what is making the request. Now, we hit a key point. Detailed context is essential for detailed audit and authorization policy. What does this mean? Without context, like who made the request, what it tried to access, and under what conditions, you can't enforce meaningful security controls or trace accountability. And now, agentic applications can involve many moving parts, multiple agents, multiple tools, different actors triggering them. You know, users might call agents, events might call agents can call tools, and agents can call other agents. This chain of interaction is dynamic, non-deterministic, and quickly becomes complex, which makes zero trust and contextual awareness all the more important. So let's look at some examples to learn what to do and what not to do. The simplest case is when a user gives their API key to the agent, and the agent just passes the same key to the tool. The issue here is that the user is delegating full control to the agent. And from the tool's perspective, it can't tell who is making the request, the user or the agent. You know, to the tool, it's the same. It receives the same API key. We've lost some context. Another approach is giving the agent a master key. So users don't even need to provide any credentials. But now, the agent can access anything, regardless of which user made the request. And different users should have different permissions. You know, I might have a GitHub repo, a private repo. I don't necessarily want Mariusz to have access to it. I'm sorry, Mariusz. Okay, so to make matters worse, in these examples, these keys are long-lived, which breaks the zero trust principle of per request verification. So how can we do better? Well, one way of avoiding handing credentials directly to the agent while preserving context is with OAuth. OAuth is an authorization model where a user can give a third-party application, for example, the agent, limited access to the user's data in another service. With OAuth, we can let the user log in through a trusted provider. The trusted provider generates an access token, which can then be received by the agent. This token is short-lived, scoped, and contains information about the user, which means every request can be tied back to an authenticated identity. Now, this is nothing new. This is standard, the standard well-known solution. And something to note is this access token could be configured so that it gives access to both the agent and the tool. This is known as token pass-through, but unfortunately, this also breaks zero trust because the same token is being reused across components. The tool can't really tell whether the request came from the user or the agent. And we lost the separation of identity and the ability to verify each request independently. Luckily, OAuth has a very powerful feature called token exchange. It lets one access token safely exchange for another. This allows the agent to get its own token to call a tool on behalf of the user without reusing the original token. By using token exchange, we preserve context and maintain separation of identities between user, agent, and tool. But for token exchange to work, each component needs to talk to the OAuth provider. The simplest way to do this would be, to give each component their own client secret. But this reintroduces long-lived credentials into the system. And as we know, long-lived credentials is the enemy to zero trust. So who here has heard of SPIFFE or SPIRE? Yeah, nice. Okay, SPIFFE is an open standard for workload identity. It defines how services can securely identify themselves by using cryptographic identities instead of passwords or API keys. SPIRE is, a reference implementation of SPIFFE, and it provides these identities. Sometimes it's called SVID, using X509 certificates or JOTs. And it already integrates with a lot of existing systems like Kubernetes, Envoy, and Vault. So when we integrate SPIFFE and SPIRE into what we've shown before, we can see that the agent can perform the token exchange by using the SPIFFE SVID instead of a client secret. Now we no longer have long-lived client secrets for agents and tools. And one more thing, lastly, if you're using an external tool, the tool might not be able to readily consume the access token that we produce. Many legacy systems are built on an older method of API keys instead of OAuth. And these tools won't know how to, use these OAuth tokens. So therefore, we propose using a secure credential store in these cases. And credential store is configured to understand the OAuth2 access token so that when a user presents the access token, the store returns an API key, which can be used to finally talk to the legacy tool. Okay, so again, we know how to do this. We've been doing this for years. These are the different ingredients. For an OAuth provider, you can use something like Keycloak, which implements OAuth2 and token exchange. We already talked about SPIFFE and SPIRE. These are all CNC projects. And for a secure credential store, you can use something like OpenBAO or Vault. And the question is, how are we going to put all these together? And now I'll pass it on to Mariusz. The key challenge is, how do these different technologies integrate?
Excellent job, Alan. Thank you so much. By the way, I was supposed to have this talk with Maia Iyer, but she's still flying because of all the diversions, so she didn't make it. I asked Alan to help me. As you can see, he did an excellent job. So thank you. Thank you. Okay, how do we bring all the things together? Let's do it. So here's what we like to have. We would like to have a user who's able to talk to agent, ask some questions, then agent able to talk to a tool, and then tool access some external service, for example, let's say GitHub, okay? Of course, agents are not the actual models. Agents are the wrappers. So they can communicate with the actual models either through the local framework like Ollama or OpenAPI or Llama Stack. So the solution is kind of quite complex. Here it is. Okay, this is all you have to do. Okay, very easy. Okay,
we can end the talk.
You don't need me for the rest of the talk. So this is all. Okay, Alan did good job. This is what I was supposed to deliver. Okay, fine. Let me walk you through it. So we have these components. Let's introduce a user. and maybe user should talk to some kind of UI to make it easier. And user, to get access, has to log in. But we don't want to pass the user credentials all the way to the system. So what we do, we introduce some access identity and access management. In this case, that will be a keycloak. And keycloak has a public access point for OIDC discovery, so other services can validate the token that they receive. Okay, so now we have to set up the user account, define some access policies in keycloak. User logs in, and is basically being redirected to keycloak and logs into keycloak. What happens there? Keycloak returns access token. An access token is crafted specifically for the agent. This token contains information about the user. So this is short-term token. There's no more identity credentials passed to the system. So we have a short token that is destined just for the agent. Now the UI needs to pass this token to the agent. And the protocol for this communication is A2A. And in fact, that's the same protocol that agent would be using if they need to talk to another agent. Okay, in order for the agent to understand and validate this access token, agent must be able to talk to keycloak. But how the keycloak identify itself how the agent identifies itself to the keycloak. There's no user involved directly on this. So we could use the secrets to make the call between the keycloak client, which is the agent. But there's a better way. If we have SPIRE, SPIRE would be able to attest the agent, which basically it's just another Kubernetes workload, and then provide it with workload identity. And that becomes agent identity. So this registration of the agent as a keycloak client happens in the init container of the pod for the agent, or it could be a sidecar for the agent. Once the agent gets the request from the user, it would pass it to the model using one of those different supported frameworks. And the model tells the agent that it needs access to a specific tool. Let's say the GitHub tool. Okay, so now we know the target for this call, for the next call, so we can execute the token exchange. The definition, who can exchange with whom, is defined in a keycloak exchange policies. So now we have a new token where the GitHub tool is the audience of this new token. And calling agent becomes, the calling agent becomes the actor in the token. And of course, the user information is also preserved, if needed, as a token subject. The communication between the agent and a tool is called MCP. That's the Model Context Protocol. MCP client is on the agent side, and the MCP server is hosted by the tool. So we used MCP streamable in our example, and the tool receives the new token that is just crafted for it. But in order to inspect and verify this token, tool needs to register with keycloak exactly the same way as the agent did. So again, SPIRE identity is being representing the tool identity, and the tool can register itself, and this time it's a tool that registers as a client to keycloak. Tool can now validate this token, and if everything is good, it can use this token to access the external service. But wait, what if this external service has no idea what this token really means? This could be some legacy application or could be some third party. They have no idea what this means. Well, Alan talked about the Vault system, so we put Vault. In this case, we use the Vault pattern, and Vault can store the external service API keys or a secret, and then exchange it for exchange the token for the secret. And of course, it has to first validate if this token was legit, so executes the call to the keycloak OIDC service to verify the signature. Once everything is fine and the policy compliant, it inspects the claims inside the token, and based on this, can release the proper security component, the API access key. Okay, so if we have this working, there is no problem to introduce multiple users. Each different user would get different level of credentials in this exchange. And of course, we don't have to use Vault. We can use any IAM service, Identity and Access Management, that could be OpenBOA or CyberArk or any other solution. Okay, so everything should be working end to end. There's one more problem. As this scales in the enterprise solutions, there will be the larger number of tools, and according to some studies, the most optimal number of tools per agent is up to 10. So if the number is bigger than 10, we start having some optimization problems. And this is when the MCP gateway comes into place. So MCP gateway aggregates large number of MCP servers into one access point. Agents connect always to this one endpoint, and that manages the rate limits. Filters are based on authentication and authorization, and then it executes dynamic routing and session handling. MCP gateway is built on the top of Envoy with production level performance. The filtering is done using context, tag annotations, security labels, and smart policies. So if you're interested in collaborating in this aspect, please visit our project link that will be at the end. This is a fully open source project under Apache license. Okay, so now back to our full picture. Even though I explained you the entire flow, I think this is pretty obvious for casual observer. Under simple inspection, this is complex. Okay, so what do? We automate everything. We bring all this functionality to the platform. So now we have Kubernetes operators, webhooks, sidecars, container inits doing all the work. So now, if you are agent developer, you only focus on developing agents. You don't have to worry about any of this identity stuff. It's done on the platform. Same with the tools. If you are a tool developer, you just focus on developing the tool. If you are a manager of this whole environment, you just define the policies, and that's all. Then user comes in, they can assess what kind of level permissions they would like to pass to the system, and the magic happens. Okay, so we brought this under a project called Agentic. So to demonstrate the value of it, we gathered this as a blueprint. So it's a Agentic project. That's like K-agent, but with Italian accent, Agentic. All right, I think it's a good name. All right, now agents developers can focus on writing agents, and tool developers writing tools. Okay, what's next? So next, we want to focus on completing the MCP gateway to make it enterprise ready. Hopefully, we can show you another presentation, end-to-end demo in March in Amsterdam, if we get accepted. We also want to put more emphasis on autonomous agents that are triggered by non-human events. The agent identity will be essential there. Observability, automated logging, processing is critical for audit. Dynamic client registration with better integrations, SPIRE, and transaction tokens. So, for a hands-on experience, please join us tomorrow to see all these concepts in action. We will be doing a workshop tutorial. It's tomorrow, 11/11 at 11:11. Come early because it will be full, even though this is ballroom. But yeah, we have collection of blogs on this work. So please take a look at the blogs. Of course, the project Agentic, very easy, Agentic.io. You can scan the QR code. It takes you directly to the Agentic project. All the information is passed there. And if you want to talk to us, you can talk on Discord. And thank you so much. Questions? It should be on. Is the microphone on, sir?
I don't know how. Oh, hey. Thanks for having this talk. This is great. One of the most severe security concerns facing in the agent is called prompt injections, and in MCP we have 2 poisoning attacks. I wonder if you have this entire security layer. Do you have anything to prevent prompt injections or mitigate that issue? Thanks.
So this is Maia's specialty. Okay, she is actually working on the prompt injection. What can we say here? So we are working closely with the MCP protocols, and we're trying to enhance our point of view as well. So we believe that the current security needs to be extended, so you can provide more information about the actual agent and the caller. So this is to respond to those concerns of the injections. Yeah.
Great, thank you.
Thank you.
Yeah, feel free to, again, come to our workshop. And by that time, Maya should definitely be here. So you can feel free to ask that question to her directly.
That's right. This is a perfect question for tomorrow when Maya comes in. She's an expert in injection. So come tomorrow.
Hey guys. So you make the assumption that because you've issued a token, that you've done your job. But how do you actually express the policies? So the tool gets this token, and that token has certain claims like the AZP, the expiration. How do you know, and how do you have a record that the tool is actually executing the policies that the token represents?
So this is already predefined in policies in Vault. So you have to define who would be the recipient of the identity that is getting based on the claims that are in a token.
Not following you. I don't see it in this type. Where's the vault?
Vault is right at the bottom. So let me make it easier here. Right here.
So the tool is getting a token and presenting that token to the vault.
Correct.
And you're saying it's up to the vault to have the right policies?
It would have to be defined in Vault in order to release the proper to the proper key.
How are those policies managed? And also, that token is being sent to the external service, and to really have zero trust, you're saying that the external service is going to trust the IAM service. Don't we need policies also in the external service to really have zero trust? Otherwise, we just have trust in the middle, but no trust on the edges.
Yeah, but you could take the same. You can take the external service. It's releasing it's releasing the secure API key that you can access it directly to you, right? Now you have to put it in a vault to store it, and will be released only if you supply certain requirements which are defined in the claims. You would never get incorrect information if the policy doesn't allow you to access it.
So you're saying that it's out of scope. Once you issue the token, everything that happens after that is out of scope.
That's right, because there's no other way at this point. Unless the external service can understand our original token, the one that we produce on Keycloak, then I don't have to worry about any of this problem.
Your example is just too simple. It would all be nice if we could reduce authorization into one AZP claim, but the world just isn't that simple, and we have complex claims. Also, we have multiple token issuers and multiple token types. So this picture of the world is just too simple.
Okay, thank you. This is just our point of view. Are we experimenting with this? And then this is where we stand today. But we welcome to continue conversation on this to increase it, improve the quality.